Okay, thanks Justin, and also thanks to APAL for the invitation here to present my research, which was a Hort Innovation project that I completed last year. And I'm going to actually talk about it in this order. So I'm going to talk about the possibilities of using other products apart from DPA as the first part of the talk, and then I'll talk about ways of possibly decontaminating in the next part of it. Okay. So the background to the project, as I'm sure you're all in the room aware of this, DPA mainly used to control superficial scald in both apples and pears. And I'm not going to talk about all the factors that are involved in superficial scald because I don't have the time. And there's some excellent reviews, including this one, Lurie and Chris Watkins, 2012. And that and any of the references that I mention here, I'm more than happy to email to you if you're interested. So superficial scald, you can see various examples there, what it looks like on both apples and pears, and it's not just on green, but also on red-coloured fruit as well. And DPA is classed as an antioxidant or antioxidant, and it's been used worldwide since the 1950s. So we've got 60 plus years of use around the world with it, and it works really, really well to control superficial scald in these products. But why the project is because, in talking about MRLs, the EU actually changed their level for MRL for acceptance of DPA. And I've got here the EU, they're wanting a 0.1 MRL residue. In Australia for apples, we're 100 times more than that with our MRL. And pears, it's really not much better, 70 times. So I know from Gavin's talk when he said about how many exporters, I think what, one hand or something came up in the room. So not many people export, but if you can see down the bottom there, it's saying European MRLs tend to dictate the future changes to other countries. So maybe, do we need to be ahead of the game here and start looking at other ways to reduce that reliance on DPA that we've had for so many years. And another reason for the project is that we have declining exports of apples and pears from Australia. Other countries are taking over from us, and also, because of this MRL, it's a costly exercise if you export and your MRL doesn't meet the stringent standards in the EU. So therefore, we need to find these alternatives to DPA. So aims of the project, investigate these alternatives to it, and then look at what's the current best practice for industry for these DPA alternatives. Then the other part of the project, as I said, to look at decontamination methodologies for people who've used DPA for many years. And then I had a prioritised list of investment options for industry for these alternatives. Now, all this is really detailed in my report, which hopefully is now available. It was initially classed as confidential, and so I'll find out from Hort Innovation if that's available now. So the methodology, it was purely a desktop study, so I didn't do any experiments with this. It was quite a short project, 4 months part-time, and I basically did lit searches through all the literature, trade publications worldwide, and as well as that, I also contacted key researchers and also key exporters to the EU to see what they did. What alternatives did they use for DPA, and also what did they do to try and decontaminate various facilities. And so with that, there was a project reference group. I came up to Shepparton, met with some of the key growers and exporters up here, and spent a couple of days up here discussing the issues and seeing the facilities, etc., with them, and consulted them, and also by email. So, who are the major exporters? So on the left-hand side, we've got apples. On the right, we've got pears. New Zealand is the chief exporter of apples to the EU, followed by Chile and then South Africa. And fairly similar with pears as well, except South Africa, Chile, Argentina, and New Zealand is further down on that list. So I contacted key growers from probably, I don't know, about 7 different countries. So Northern America, Canada, South America, New Zealand, then also South Africa and Italy. So, on to the alternatives for DPA. Okay, first thing, good news, yes, there are alternatives to it. And the first one I won't spend a lot of time talking about because I think Tito, our next speaker, will be talking about it, and also tomorrow, for those of you here, you'll be doing some tours, for example, to Masalki Cool Stores, who use this technology. So, DCA, that's it's a dynamic controlled atmosphere where you're actually reducing the oxygen levels so really, really low, just above the sort of anaerobic point. And in order to detect that point where the fruit are really stressed, they're using chlorophyll fluorescence. It's been around for a long time. This is an example. So Robert Prange, who spoke at the seminar, I think in 2016, he was one of the key drivers for that. So it's been used successfully since 2004, and more countries around the world are using it. But the problem is that because you're really looking at very sort of finite levels here and fine just above the limits, you need to have a non-leaky cool room. So if your cool room leaks, it's not going to be as easy to use this. And the other thing is that it could be quite expensive for some growers to implement. Otherwise, maybe using this as a cooperative and going into new cool rooms as a cooperative, because the cost, and this was last year, about $50,000 for a 1,000 bin room. But a new cool room with that DCA system, this is everything, including all the electrics, the etc., 500,000. So, next option are the various chemical treatments. And the first one is 1-MCP or Smart Fresh that you're all probably using anyway as the ethylene inhibitor. Now, this works really well. It prevents superficial scald in pears in particular, but it does inhibit ripening in pears. And there are some ways around that, and that some research says to apply the Smart Fresh simultaneously with ethylene. Another way, Hannah James, I see sitting over there, and she did a great video in 2016 talking about if the pears are conditioned to 10 degrees Celsius and then cooled before it's applied. That works quite well. The other thing to consider is the cultivar of pear. It's actually quite different responses. So you can see there are two different pear cultivars, and you've got 50 nanolitres per litre compared with 300. So important to consider that. Next option is something called Resveratrol. And Resveratrol, it's kind of a bit of a buzzword in this whole sort of antioxidant type industry. So grapeseed, we hear berries and things, all these dark coloured fruits are really good for us. It's actually a phenolic compound that polyphenol that the plants produce, and it's kind of a defence mechanism. Often it's like UV damage or insect damage, and this is perceived as good for us as well. So that was, I think, the reasoning behind this research, and it's fairly recent research as well, this one. But what I thought was interesting is no significant difference. So statistical tests done, no difference between 1-MCP and DPA. So this is in an apple cultivar and in pears. So this is research that came out of China. The problem is the cost. It's quite prohibitive because we're looking here at about $400 a kilo. And when you consider that DPA is $45 a kilo, that I think, as good as it seems at this point, I think that rules it out. But all is not lost because we've got a couple of other options. The next one is called stripped plant oils, and that means that the vitamin E is removed from it, and often by centrifugation that they remove it. This research has been around for a while. Dew and Curry, this is in the United States, they did this work. And it's as effective as DPA. And this was on delicious apples. Oops, what just happened? Okay, all right. Now the cost, I have got across through this at $1,000 a kilo because they don't seem to make this anymore. So I contacted so many chemical companies, and the ones that finally did get back to me after my follow-up emails, it turns out, no, they don't make it. So that price was on a historic website, so it's not available. I went back into the history of their website, and it was $1,000 a kilo. But they're speaking to a chemist at CSIRO in Geelong, and he was saying, look, it's pretty easy to make up. So if you wanted to consider that, that I think would be something quite interesting to pursue. Next one I want to talk about is this thing called Lovastatin. And Lovastatin, if you think about this, you might think, okay, statins, you know, cholesterol-lowering drug. Yes, it is. It was first isolated from oyster mushrooms, hence I've got my oyster mushroom slide, and that is also as effective as DPA. And here we've got on both a couple of cultivars of apples and also pears as well. The cost of this one, same as DPA. So this one is looking actually quite promising, the Lovastatin, same price as DPA, $45 a kilo. The last slot that I want to talk about in terms of our options are various antioxidants. So don't forget that DPA is classed as an antioxidant, and so that kind of made me think, well, you know, did they look at this? So I went back to the original work of that was done with DPA by Smock in the 50s, and what I found was that he tested only at 500 parts per million, both those organic acids, citric and ascorbic, but he tested the DPA at 1,000 and 2,000 ppm, so heaps higher concentration. And it seems to me, from that work, we ended up with going down the route of DPA, and it was so successful that we ended up forgetting about these other antioxidants, which I thought was quite interesting. We talked earlier about Colin Little doing a lot of his research. So this was Chillu and Little. They did this work out at Knoxfield, and they looked at both those acids, citric and ascorbic, at 3 and 10 grams per litre on Granny Smith apples. It reduced superficial scald, but they did this huge trial in that work, and they didn't test other concentrations, but they recommended that higher concentrations of those two acids should be used. Cost, $10 a kilo, so, you know, pretty cheap. Now, while I'm talking about antioxidants, I also want to talk about just one slide here about internal browning. Even though that wasn't part of the project, I know that that is a concern, obviously, for a lot of you. So when the fruit, obviously, as you know, it's in various controlled atmospheres, and that is creating an abiotic stress on the plant because, or the fruit, because of the low oxygen, the increase in CO2 that happens over time, and the low temperatures. So even though, and obviously this is part of that DCA-CF system, which you can really test, but aerobic respiration is slowed at that temperature, but it can become anaerobic. It can lead to that anaerobic respiration occurring. And of course, anaerobic is not as efficient a respiration that happens. When this occurs, this then leads, and this is a recent paper here, 2014, and quite a few authors, because it was a molecular biology paper, but it also talked about, sorry, I just looked at the time, just did a slight panic there. So they, some of the authors, we had Chris Watkins, and one of those great work this paper did. So they found that this then led to membrane damage because you have reactive oxygen species that are produced because of that low oxygen. When you get the membrane damage, therefore the cells actually are getting disrupted. And when those cells get disrupted, normally what happens is that you have the phenolic compounds and the enzyme that works, the polyphenol oxidase, they're in separate compartments within the cell. But when those cell walls are broken down, there's nothing to keep them apart. So they come together and you end up with browning. And there's a sort of different rate of oxygen, obviously, in that cross-section of the fruit. It's less oxygen towards the centre of the fruit than the outside. And They found, therefore, that ascorbic acid was actually lower towards the centre of the fruit, and therefore they actually suggested a protective role for ascorbic acid has been proposed by them. So I just think that that is definitely something worth considering. Okay, I'm going to move on to DPA removal from facilities. First thing to say is there's very little information available on this, and the information tends to be fairly old. People seem not to have been doing much about it recently, because so far no method has been completely successful, but we do have some options. Okay, the first one, well, the expensive building of the new cool room facilities. Otherwise, there are various heat treatments that can work. So Angus Crawford did some work with some growers, and he gave me this information, and they were using 40 degrees Celsius, so heating the rooms up for 2 days and then venting the rooms. They did do some work with ozone as well, but I'm not sure what level of ozone, and there's some issues with ozone because some of the work was at 800 ppm, and that's incredibly dangerous. Like 5 ppm is considered dangerous to life. So I think ozone treatment is not the way to go, but heat treatment may be. The other option, and this was an Italian paper that Dario kindly translated for me, high pressure washing, and they used 10% soda lime with it. So unfortunately there wasn't a lot of detail, it wasn't a sort of scientific paper, but I'm thinking that it may be worth combining, say, high pressure washing with a pH of less than 5, because the DPA between pH 5 and 9, it's pretty stable, but if you get to a more acidic than pH 5, and you add a surfactant to it, as in like a detergent, because DPA is a very fat-loving substance, so break it up with the high pressure washing, and then maybe high pressure washing with heat as well with it. And then that, combining all those things, seems to be, I think, the best option. That type of treatment would also be really useful for the bins and various aspects of the packing chain as well. So the way forward. So yes, there are viable alternatives to DPA that I think are definitely worth pursuing if people want to move away from that. So the recommendations would be to test some of those ones that I mentioned to you that seem to be cost effective, test them under Australian conditions, the different growing regions of Australia. And the other thing would be to test the DPA removal from cool rooms when they're empty. So you can heat them up and then vent out into the atmosphere after doing the high pressure washing with the acidic surfactant. So finally, when I talk to people, they say, yes, that level of DPA will dissipate over time, but I seem to get pretty different time estimates from a few years to 8 years. And that, I think, is... So Robert Prange and Chris Watkins both gave me both ends of the scale with that. It's a pretty risky business if you're going to be trying to export and you don't know. So, therefore, having maybe a collective of DPA-free cool rooms might be an idea. And also testing maybe what goes into them. And that's it. So all my acknowledgements, the various people that I asked questions of. Thank you.
My last experience in exporting fruit to the UK were pink ladies. They left Australia, DPA free, hadn't been in any rooms or anything. They were tested before they left, DPA clean. When they got to the UK, taken out of the shipping container, DPA contaminant, rejected. That was 3 years ago. That was my last experience exporting.
I'm really sorry to hear that, because that's...
So was I.
I hate to think how much that cost you. I'm imagining how much. So that makes me think that, do we need some certification scheme where you've got, this was DPA free when it left Australia, and also maybe testing of that container that it was in. So because it will get into, and there have been tests, I think that was part of Angus's work in that study I mentioned, and other South Africans also have done this. Fruit particularly that's around the sides of the bin, if it's in contact, because of this substance just getting through from the edges. So all I can think is some certification scheme is required, not just from your end, but when it's going into that container, and so that you've got a fallback and saying, well, hey, I've done the right thing, and the shipping container people. And that's where testing is, I think maybe we have to go that way.